So here we go with the last question from practice paper C, AS Pure Practice Paper C. The value of a car V in pounds. The value of a car V in pounds is modelled by the equation V is equal to A plus BT, where A and B are constants and T is the number of years since the car was purchased. The line A shown in the diagram illustrates the linear relationship between T and log to the base 4 of V for T greater or equal to 0. And the line meets the vertical axis at 0 log to the base 4 of 40,000, and the gradient of L is minus a tenth. Okay, quite a lot of information there. So, write down the equation of L. So, A. Well, it's a straight line, so it's going to be of the form y equals mx plus c. I've capitalised the y and x because they're representing different variables. So in this case, the y variable is our y-axis, so that's log to the base 4 of v. So we're going to have log to the base 4 of v, log to the base 4 of v is equal to m, which we were given in the question here. The gradient of the line is minus a tenth. So we get minus a tenth, or negative a tenth, x, and the x-axis on this occasion is t. So we're going to get t plus our y-intercept, which is log to the base 4 of 40,000, taken from the question and or the graph. So that is part A. Part B. Find the exact values of A and B. Well, we're told to start with V is equal to AB to the T. So if we can convert V equals AB to the T into the form of the above, we should be in the right place. So to get the above, we're going to take it log to the base 4. So log to the base 4 of V is equal log to the base 4 of AB to the T. And we now have to use our log laws. So the first thing to do is to separate the A and the B because they're multiplied together. So we get log to the base 4 of A plus log to the base 4 of B to the T. It's important that we notice here that it's B to the power T. It's B to the power T, not AB all to the power T, otherwise it would be different. So the first thing we've then done is use our log laws. Yeah, and log of AB is equal to log of A plus log of B. Now I'm going to use log of A to the n equals n log A. And if you haven't done the learning, you won't see these things in the middle of questions like this. So that gives us log to the base 4 of V is equal to log to the base 4 of little a plus t log to the base 4 of B. So now we can equate. We can see that log to the base 4 of A is like our y value, or sorry, our c value, which is there. Yeah, so again down here, we've got y equals c plus xm. I hope you can see why I've changed the order there. So that's our variable y. That's that bit. Our variable is time, so that's got to correspond to the capital X. So this bit is our gradient, and this is our constant that's added on C. So when we come up to here, that's our y, that's our variable, going with that. This is our gradient, so that's going to be going with the log to the base 4 of B, and here's our y-intercept there. So we get C, so log to the base 4 of 40,000 is equal to log to the base 4 of A. So A must be 40,000 straight away. Then we look at the next bit going across. T log to the base 4 of B. There's our T. So log to the base 4 of B must equal negative a tenth. So log to the base 4 of B is equal to negative 1/10. So inverse or our knowledge of logs tells us then that B equals to what power must be 4 be raised to get B? So B equals 4 to the negative 10th. So that's part B finished. Part C. With reference to the model, interpret the values of the constant A and B. So if you go back to the original model, up here, what's A and B? Well, A must be the value at the start. So when t equals 0, B is equal to, sorry, let's write that out again. So V is equal to AB to the t, so we can see at t equals 0, B to the 0 must equal 1, therefore V equals A. So A, which is equal to 40,000, so that must be the initial value of whatever it was, I've forgotten, a car, and so it's the initial value of the car. Okay, so that's the A. B, well, if we look at B, it's going to be the rate of depreciation. Yeah, so B equal 4 to the negative a tenth is going to be how quickly it decreases in value. So it's the rate of depreciation. Not sure how you spell that. I hope I've got that right. Okay, and you can tap that in a calculator, and B comes out to be approximately 0.87. So therefore loses 13%. Yeah, 1 take away 0.87 is 0.13, so it loses 13% each year. Okay, next, part D. Find the value of the car after 7 years. Well, we can now just substitute that in, can't we? D, V is equal to A, which was 40,000. B is 4 to the negative 10, tenth, all to the power 7 at t equals 7. Tap it in the calculator, and how accurate do we want it? Value of the car after 7 years. Certainly the nearest pound is as much as we should give. I would probably round that to 15,000. You might go to 15,200. Yeah. Okay. That's part D. Part E. So it state a limitation of the model. Sorry, we haven't done part E. Sorry, I've read the wrong bit. Part E. after how many years is the value of the car less than 10,000? So we want V to be less than 10,000. So that's A to the BT, so 40,000 times 4 to the negative 10th has got to be less than, what did it say in the question? Less than 10,000. So 4 to the negative 10th. That had a T on, didn't it? Because it's B to the T. So 4 to the negative 10th to the T has got to be less than a quarter. So we've now got to solve that. So let's take log to the base 4 of both sides. So log to the base 4 of 4 to the negative 10th to t is less than log to the base 4 of a quarter. So this will give negative t over 10 is less than negative 1. So negative t is less than minus 10. So t is greater than 10 years. Divided by a negative reverses the inequality. Divide by negative 1 reverses inequality, or you can add the t across and add the 10 across, and then you get the same thing. Okay, so what was the actual question? After how many years is the value of the car less than 10,000? So after 10 years is the actual answer. After. Yeah, anything over 10 years, it'll be worth less than that. After 10 years, value of car is less than £10,000. Okay. Part F. State a limitation of the model. I suppose that the longer the time goes on, the more likely there are to be other things come into play, like accidents or the total mileage that it's gone. So it's the amount of wear and tear. So not as accurate as time increases due to the effects of the mileage done, wear and tear kind of stuff. Okay, hope that's clear.